I'm Anika Viswesh. I'm excited to introduce our next speaker, Shreyansh Daftry, at the African Science Buskers Festival. Shreyansh Daftry is a research scientist at the NASA Jet Propulsion Laboratory in Pasadena, California. At NASA, he works at the intersection of artificial intelligence and space technology to help develop the next generation of intelligent robots for Earth, Moon, Mars, and beyond. Shreyansh obtained his MS degree in robotics and AI from the School of Computer Science at Carnegie Mellon University, and his BS degree in electrical engineering from Manipal University, India. His lifelong ambition is to promote both the exploration of space and the improvement of sustainable living on Earth. Please welcome Shreyansh Daftry.
Thank you so much, Anika. Thank you for the invitation to you and Mr. Knowledge for giving me the opportunity to talk at the festival. Could you share my screen? Yeah, great, perfect. So thank you everyone for joining. As Anika said, I'm a research scientist at NASA's Jet Propulsion Laboratory, and today I'll talk to you guys about some of the things that excite me, namely artificial intelligence, and the space exploration and my role at NASA about working at the intersection of both of them. I will quickly move to the slideshow so that you guys can see the whole slide. And if there is any trouble, Anika, please let me know because I won't be able to see the window anymore. Okay, so thanks for joining in, everyone. I hope everybody is healthy and staying safe in these crazy times. So let's start the talk about with the definition of artificial intelligence itself. The way I like to define artificial intelligence in the most broad term is it's a collective term for any computer system that can basically sense its environment, think, learn, and take actions just like humans would do. And it is in a lot of ways, as defined here by Professor Andrew Ng, it's called as the new electricity. And the reason for that is for a lot of things and across all the industries, you're basically seeing a revolution in which use of artificial intelligence and related technologies is enabling basically huge leaps in progress and allowing us to make great strides and impact across the world for different industries. So why is so with this concept of artificial intelligence, is this something new? Not really. We have been seeing artificial intelligence and development of those technologies for almost 6 to 7 decades now. And what we are seeing now in the last few years and why it has suddenly become a hype word is because of some emerging technologies like machine learning and deep learning that I'll briefly introduce. And what is the key difference in how artificial intelligence was in the last few decades and why it's suddenly becoming so important and suddenly how it's making a huge impact across industries. So one key difference so previously when computer programmers or software engineers used to think of writing programs for computers to make decisions, they would basically have these long, huge programming codes with rules that they would manually write down. This would allow the computer to make simple decisions. For example, like if they want to add things like 2 plus 2, then we would have specific rules that we would tell the computer that it can follow and perform those actions. However, now as things start to become complicated, so for example, if now you want the computer to play chess, now how do you start going about writing down the rules for it? For some of the people among you who actually play chess, now if I ask you that write down all possible strategies, all possible rules, all possible actions that you might want to take when you're playing a game of chess, that's a very complicated set of rules now. And it's almost impossible to actually write down every possible cases that can happen during a game. And this is something human brain is really good at doing. We do this so easily that we don't even know how to do this. Now, so this was a problem for a traditional way in how we used to do artificial intelligence. And this is where we had a new paradigm shift recently, where emerging technology called machine learning changed the way we basically do artificial intelligence. So on the left, what you see is traditional programming, where you would have something like we had data and we had program. So that would be the example where we want to add things like 2 plus 2 or do any other mathematical operation, and the computer would basically have an output for that. Now, when we don't know how to actually write the program, we switch it around. So what machine learning does is rather than giving it a set of rules, it tells us the set of rules by just looking at data. And this is similar to how a human baby learn or a human children learn. When we are growing up, we basically look at things, we look around our environment, we experience things. And based on that experience, we actually make our own rules of how the world works. And this is exactly what we are now teaching machines to do. And this paradigm of actually learning through data has enabled huge progress in the field of artificial intelligence. And AI is basically a revolution that's happening all around us. It's not something that you just see in university research labs or academic work. Everywhere around you, basically, you can see impact of artificial intelligence from your phone, where you might be using it on Google Maps, to finance and finance industry, where a lot of people now use algorithms to basically make future predictions of data, to even simple things like the TV that you watch and decisions like, for example, what should be a good movie that I should watch next that Netflix tries to recommend you, is all made using artificial intelligence and machine learning. So where do I come from? Where do I come in here? So my role within in the work I do is basically to make machines see things, and that's a field within artificial intelligence that we call computer vision. So, and this is something that humans do really good at, and we have our eyes through which we see the world, and what we see is basically processed as signals and sent to our brain, which actually makes intelligent decisions about what we are seeing. So my part and my role is basically to develop algorithms and mathematical models that could allow machines to, when they see an image using cameras, it becomes just numbers. So on the left, what you see is a picture of what a machine would really see if it doesn't know how to interpret them or doesn't know how to use artificial intelligence to make sense out of them. And my role is to basically bridge the gap between what's on the left, so looking at these random set of numbers which don't really make sense even to humans, and then trying to make models that could allow us to then make sense out of it. For example, where is a car if you're on the road? Or when you take a picture, then where is your face? Are you smiling? Are you not? And even facial recognition. These are the kinds of things that computer vision engineer typically do. And in my role, what I try to do is I focus on making this for robotic application. So if it's a intelligent machine like a self-driving car, or even a robot that's working in agricultural field, how can it make intelligent decisions based on what it's seeing? That's really the summary of the kind of work in which that's the area in which I work on. So just to give you a brief background about my own career path and education background and how I moved. So I'm originally born and brought up in India. The first red dot you see on the right, that's a city called Calcutta. Um, I did most of my schooling in India and even my undergraduate degree, as Anika had mentioned at the beginning, from Manipal Institute of Technology, where I did a bachelor's in electrical engineering. During undergrad, I did a lot of work in robotics. I was very interested in how the brain works in building intelligent machines. So I really had a lot of hands-on experience in trying to build toy robots, making them trying to do follow a line or do other things, and eventually taking part in competitions, which allowed me to build more interesting robots. As a result, I found my interest in robotics and AI and decided to pursue a career in that field. And in order to do that, I basically started looking for internships and other people I could work with that would give me more real world experience in how some of these things work. In that quest, I basically moved around, did internships at different parts of the world, uh, and then spent a couple of years in Europe, where I worked at a university trying to do research and learning more about computer vision. Eventually, I moved to the US, where I did a master's degree in robotics and AI at Carnegie Mellon University, where I worked on trying to build drones that could actually fly like birds. And eventually, a lot of that basically combined together with my childhood passion of space exploration ended up with my role at NASA. So one of the things I know a lot of people here are interested in is uh, about career paths and career journeys in their own life. So if there are any questions related to even career and not just about the technical work I do, I'll be happy to answer those questions in the end. So this is just a portfolio of some of the interesting robots I had experience of working with while I was studying. Uh, on the top left, you see a drone that we had built that was used in architecture industry. We used to send out these drones, and what these would do is create a map of the building while it's under construction. And this allows civil engineers and other architects to actually see their building in live while it's coming up and be able to uh, do very quick feedback rather than trying to measure everything with really expensive sensors and manual labor. Uh, Similarly, on the right, you see some of the other robots that I worked on that helped me explore either for oil and gas industry or for even for a NASA project. Even before I joined NASA, I worked on a project where it allowed me to build robots that could go onto the surface of Moon and explore some of the caves over there. So throughout my undergraduate degree, what I did was gather a lot of hands-on experience working with robotics and AI, trying to learn the challenges of working with some of these robots. So eventually, when I pursue a career or pursue my graduate school, a lot of this experience became handy. This eventually led to my role and my current role at NASA, which is about AI for space exploration. So this journey was really very interesting, and I'm very lucky and fortunate to uh, have found two things that I really love for. As I mentioned, robotics and AI, where a lot of my skill set lies, and and space exploration, which as a child I was that's all I wanted to do was basically go to Mars or fly in space. So those were, and luckily, Jet Propulsion Laboratory, where I currently work, is one of the only places in the world which allows me to actually pursue both of them. And the timing was great too, because artificial intelligence was just about taking off, and there was a renewed interest in doing space exploration. And as it turns out, and what I'll be talking to you about next, is how artificial intelligence is actually uh, becoming one of the key ingredients that's allowing us to pursue the next frontier in space exploration. So, as some of you may know, or might be thinking, why does NASA even need space exploration? NASA even needs artificial intelligence. Uh, so, for 6 to 7 decades, NASA has been building great spacecraft. We've developed some of the best machines humankind have ever built, and they have expanded our knowledge of humanity. We have built spacecraft that have gone from Moon and Mars to all the way to the outer solar system. And even two of our spacecraft, like the ones that you see in the pictures here, the Voyager spacecraft, Voyager 1 and Voyager 2, are actually now not just in our solar system, but are the first man-made objects to actually go beyond our solar system into interstellar space. As we talk today, we still have those spacecraft exploring interstellar space and going further and further away uh, and increasing our knowledge of our universe together. So we have, so the message I'm trying to say is that we've been building really great machines that have told us so much about uh, the universe, how it existed, its history, and potentially answering questions about our own existence. But one of the key things I want you to note is that while we have done a lot of these great exploration, as a roboticist, I would not call some of these robots yet intelligent. So when we landed on the moon, on the left you see the picture from one of the first Apollo missions where we landed humans on the moon. Uh, One of the key reasons we were able to achieve that huge milestone was because we had a human brain, a really intelligent human brain sitting inside the lander, which was able to successfully land the spacecraft on the surface of Moon, which is a very challenging part of the whole mission, which is still to date impossible for a machine to do on its own. On the right, what you see is the picture of the Curiosity rover on Mars. The Curiosity rover has been on the surface of Mars and exploring that surface for almost 8 to 9 years now. And it has told us so much about the history of Mars and answered questions that were for centuries a puzzle to humankind. But one of the key reasons we can do this so well and we have been able to explore Mars so nicely is because there's always a team of 100 plus humans sitting here at the mission control room at NASA, which are operating these rovers. And that's what you see in the picture below, where we have this is the mission control room from the Jet Propulsion Laboratory, and we are always talking to the Mars rovers multiple times a day, and not just the Mars rovers, but almost every spacecraft that we have sent across the solar system. So a lot of this is actually behind the scenes is done by humans which are sitting and using their own brain power and intelligence to do this. But this is not a scalable solution. Right? We've done this for 5 to 7 decades. This is definitely not something we could do, or at least I believe we could not do this for the next 5 to 7 decades. And one of the main reasons for that is just pure distance. So what you see here in the slide is the distance between Earth and some of the more interesting bodies where you want to be going in the future. So for example, if we just have to send a robot to Mars, now we can because it's, even though it's still so far in terms of the scales at the universe level, it's pretty close. So if we send a radio signal to Moon, it would just take a couple of seconds to actually get the signal. So in principle, you don't even need an intelligent robot when you go to the Moon. You can pretty much just joystick that rover around and it'll be fine. And that's what we've done in the past when we have sent robots to the Moon. Now, when we go to Mars, while we can send signals to the rover and we can still talk to the rover a couple of times a day, the time between sending a signal to Mars and the rover receiving and reacting to this is in the order of almost 20 to 30 minutes, or sometimes even an hour, depending on the distance between Earth and Mars. So now that's fine for actually operating rovers on Mars, but it is not good if we need to make real-time decisions. So for example, if the Mars rover is in a critical failure, or if there's something urgent about to happen where it's going to get stuck, or it's going to fall into a problem where that would lead to the mission being ended, then that is a problem, and humans at that point cannot control it. So it needs to have the decision making and the intelligence so that it could actually operate with sufficient confidence in those times. Now, this challenge only becomes more and more difficult as we start to go further away. What you see here in the picture on the right is Europa. So for people who don't know, Europa is one of the moons of Jupiter, and it's one of the most interesting places in the solar system because we believe this is the highest probable places where we might find signs of life beyond Earth. It's an icy planet. So what you see on the surface is actually, it's made up of ice. And the scientists believe that below that surface of ice, there are oceans of water, just like here on Earth. So if you would imagine how the Arctic and the Antarctic regions here on Earth are, that's very similar to what we see here, a lot of the same kinds of features in Europa. So it's a very, very, very interesting area, that interesting target body where we would want to send our future spacecrafts to so that they can actually go do science on them and study and hopefully find signs of life. Now, one of the challenges with that is just how far Europa is. If we have to just send a signal to Europa, it would take almost an hour just for the signal to reach there from here at the speed of light. Now, if we send a robot there, it is almost impossible for the humans to do anything or be in the loop with trying to have a communication with the robot. So once we send the robot there, for a large part, the robot has to operate completely independently. And this is one reason why, as we move forward, we need more and more autonomous systems which can behave and make decisions on their own. Apart from distance, another key reason why we need AI is just the scale and the economics of how the space industry is growing. On the left, what you see is a picture of all the satellites which are currently orbiting Earth. And this is already a few years ago and growing exponentially. On the right, you see a vision of what someday a Mars colony would look like. Now, right now, we only have 1 or 2 rovers and spacecraft that are operating, and it's okay for humans to be controlling those. But if we have millions or hundreds of thousands or even millions of these assets in space, it's impossible to imagine that we would have 10 to 15 or even 100 people for each of those assets to be managed here on Earth. So this will become where this would come to a point where these things need to just work on their own rather than communicating back to Earth. And in order to do this, we need AI and artificial intelligence. So here in this slide, we've tried to, in our team, try to map a few areas within robotics that would be key capabilities that would help for future missions in AI. While my team works on all of these different areas, and this would work for different surface mission, landing missions, depending on even if you're going to the moon or Mars. I will be talking to you mostly about autonomous navigation in this talk and show you some of the work we've been doing recently for Mars rover navigation and how that could enable the future missions to Mars. So let me get started on autonomous. How do Mars rovers safely navigate currently with surface and orbital imagery? On the left image you see is an image that's taken from the camera on the rover, and on the right what you see is an image of the same area but taken from the orbit. The way we operate and navigate our rovers is by having human operators that we call rover planners that basically look at these images and then make decisions as to how to navigate the rover. So for example, when you have to decide, for example, if you're sitting in a room, if you would be going out from the room, or how would you navigate yourself? How would you find a way so that you don't collide into something? That's the kind of challenge that's the same challenge that the Mars rovers have to operate so that they can safely navigate from point A to point B. And when the human rovers when the human operators make those decisions, they use two kinds of features. One is textural features and the geometric features. So what I mean by that is when the for textural features are basically things like that's a rock in front of it, or that's basically this area is sandy, this area is solid, and if I go in this area, I'm going to basically have my wheels will sink in the ground. This is the same kind of uh, decision making that typically humans would go. So for example, I would not try to walk on water because I would fall in it, or I would rather find a hard surface or a bridge where I can walk on top of it. Or if I'm trying to walk in mud versus a very well paved surface. These are the kinds of decisions you are constantly doing when you're walking. And for the Mars rovers, what we currently do is they have certain algorithms that run on board, but they only make decisions out of the geometric features. So what you see is the same image, but overlaid with features like the topology of the region. So there is a big mountain in front of it, or there is a rock in front of it. It only has the capabilities currently to make decisions like which are more geometric in nature. But that is very limiting because one of the challenges that brings is the kind of things that I said in the previous slide, where it cannot interpret where a sand is or where different kinds of dangers are. And this has led to a lot of problems in the past for us. One of the biggest issues that we have had in some of the past missions is areas where the Mars rover has got stuck in sand. And let me play that again. So if you see the slide here, it's basically this was the illustration from the region where the Mars rover was actually stuck for several months, and it took almost 6 to 8 months for us to get the Mars rover out of sand back from it. So in the future, when we don't have human operators here trying to control rovers, what we would need is these Mars rovers to have an intelligent capability that could make decisions for itself, where to basically make where sand is and where sand is not. And this is what we have been developing. So over the last couple of years, I've been working on an algorithm along with some of my teammates to provide these kinds of decision-making class capabilities that we call SPOC. And it's basically what is a terrain classifier. So once the Mars rover sees an image of its surrounding, what's in front of it, it tries to make decisions in different kinds of terrains. Is it a ripple terrain, or is it like a smooth terrain where it can easily go over, or is it like a big sharp rocks where you don't want to go because you will probably break your wheels? These are the kinds of capabilities that the Mars rover will now have. And in order to build this AI, we actually went out and one of the main challenges with building machine learning technologies is how do you these require a lot of data. As I had mentioned, these learn from data and experience. So in order to be able to make a good model, we need really good data. Now, in order to do that, we created this crowdsource campaign recently called AI for Mars, and this is open to also and especially targeted at at children and kids who would like to help us build AI for Mars rovers. So, if some of you might be interested in helping us contribute to making Mars rovers more intelligent, then Google for AI for Mars or go on this link below. And what you can do is basically you will see a lot of Mars images, and then based on your own intelligence, you can help us label these images and tell the Mars rover, this is a sand, this is a rock, you should go here, you should not go here, and these kinds of things. And once you do that, we'll be using the data that you provide us and helping to train our Mars rovers even better. So I would highly encourage some of you to go and try this and help us build more intelligent Mars rovers. So we're also using these kinds of technologies to build something like a Google map on Mars. So just like we did terrain classification on the surface imagery, we also extend that for things to do on orbital imagery. So what now you can imagine is with that kind of thing, if you're on 2 points on, so imagine you're across 2 different points on the continent of Africa, and basically you want to go from point A to point B, and you want to be told the best one. So typically on Earth, you would use Google Maps or something equivalent to that. But there's nothing like that on Mars. So we've been building these kinds of technologies that allow us to use the same AI technology to build Google Maps on Mars. And all of these technologies that I just talked to you about, we've been deploying them developing them in the context of the Mars Perseverance rover. So that's the next Mars rover, which is currently, as we talk, on its way to Mars. And the illustration is shown here with all the instruments that will be going with the Mars rover to Mars. And one of the main science goals of the Mars rover is to actually study. These are actually the four major science goals that the Mars rover will be doing for us. So it will look for habitability. So has there been any evidence of past life on Mars? And try to seek biosignatures that would allow and this is biosignatures that would be a great sign for if there was life ever on Mars, or if there was even a potential for life on Mars. We would also be collecting samples that would hope that a future mission would allow us to bring back to Earth so that we could do scientific experiments with pieces of Mars here on Earth. But most of all, and at least for me, the most exciting part about what this Mars rover will be doing will be helping lay a foundation for future human exploration. And in order to do this, it'll be doing some scientific experiments, like even generating oxygen in the atmosphere of Mars, which is a key aspect that would allow us to sustain human life, sustainable human exploration of future missions. So this is actually the picture of the real Mars, the Mars Perseverance rover. This was taken in January of this year, just about the time when the whole Mars rover was completed and ready to be shipped to the Kennedy Space Center. And this is the flight assembly center. The spacecraft assembly facility at the Jet Propulsion Laboratory. And this is where all the different parts of the spacecraft, once it has been built, is brought together so that it could be put together and the whole spacecraft is made ready. In the center, you see the Mars 2020 rover. On the right, you see the cruise stage, which basically takes the rover from Earth to Mars. So along with the Mars rover, one of my favorite parts about that's happening with the Mars 2020 mission is that we are also sending a very small helicopter along with it, as you see in the video right now. It's called the Ingenuity helicopter, and what it will be doing is, for the first time ever, we'll be flying another machine on another planet. So till now, we have never had an aerial vehicle fly on another target body. And till now, it was thought that it is almost impossible to actually fly on Mars because it has only 1% the atmosphere that of Earth. But this is something that is going it's basically hitchhiking its way to Mars, and hopefully in February it'll be using AI technologies like what you see in the video right now to navigate itself on the surface of Mars and take pictures like we have never seen before from several hundreds of meters high. This is the actual picture of the Mars helicopter that will be flying on the surface of Mars. This was right after it was completed and before it was integrated below the belly band of the rover. And these are some great shots taken just a few weeks ago when the Mars 2020 mission that you're seeing on. So if you look at closely at the top of the rocket there, you see the Mars. It's basically the whole capsule. Basically, that's where the Mars 2020 rover, along with the helicopter, sits. And it was launched very beautifully from the Kennedy Space Center just a few weeks ago. If you go to the NASA website, you can even track currently the position of the rover as it's on its way to Mars. So come February of next year, the Mars rover will be landing on the surface of Mars, and hopefully we will be seeing a successful first flight of the Mars helicopter on another planet. So along with working on the Perseverance rover and the Mars helicopter and developing AI technologies for that, I've been also working a bit on looking at some of the future missions. And here you see some of the systems that we are kind of developing for that would allow us to do future exploration of not just Mars, but even other planets like Europa. So in the center, what you see is a robot called Lemur that we've been developing, which is a rock climbing robot, and it would allow us to actually climb on surfaces of rocks and do science for us. Now, you can imagine that even with a helicopter and a rover, we can never really get that close to a cliff and do science on this. And this is very interesting for scientists because scientists, that's where most of the interesting science are. If you imagine a canyon on Earth, just by looking at the canyon, you get an entire history of the planet. And geologists love going to these places. And this is the same for other planets, where just rather than traversing the whole planet and doing science by sampling a few rocks, we would want to go to places where we could see this history of planet itself in one shot. Similarly, on the right, you see a version of the robot that we've been building for that could actually ski its way on other planets. Because, for example, if you're going to icy planets, you can't build a rover that would work the same way it would work on Mars. So we've been building new technology, new wheel technologies, and intelligent capabilities that would allow, similar to the ones I showed, to not just figure out where sand is versus rock, but also to help us to figure out how to walk on icy terrains versus regular terrains. This is another, so in the middle of the picture we had of Lemur. This is a field test that we had done with Lemur. And we tried to, this is a region in New Mexico where we have lava tubes, which are basically these underground caves, which are very similar to the ones you see on Mars. So on the top right is a similar lava tube that you see from our orbital image on Moon, sorry, not Mars. And one reason we want to explore these kinds of areas is because they have a very similar environmental property that could sustain life if humans would want to go. So that's the reason that before humans can actually go and live in these kinds of areas on Moon and Mars, we would want to send robots that could allow us to explore this and understand these areas better. So the kind of AI technologies that I showed you for terrain classification, we've been also deploying that for rock climbing robots. So the decision there is, can these robots, as they're climbing, can they make a decision to, okay, where should we put a hold so that it doesn't fall off? And this is, again, the same kind of human brain activity that you would see from a rock climber. And this is a video of a field test that we did in New Mexico, where we deployed this rover to actually basically climb on rock. Okay, in the interest of time, I'll move forward. And this is one of the last things I'll show in terms of the interesting, cool robots we've had the fortune to work, we're fortunate to work with. And this is a snake-like robot that we call EELS. It's basically another very interesting body that we have is called Enceladus, and it's one of the moons of Saturn, as you see in the visualization here. Now, the interesting part about this place is that we have these hyperjets of potentially water coming out of the planet. So, and this is this is great because, and these pictures, we had pictures taken from the Cassini spacecraft that showed us some of these uh, hyperjets coming out and oozing from from the surface of the planet, and we don't really know exactly what they are, and that's why we want to send intelligent robots like this that could actually go to that place and go really deep down these very thin crevasses. So this is a kind of place, again, a rover cannot go. It's these crevasses could be hundreds of meters or even kilometers deep. And what we'd want is a snake robot like this that we are developing that could go in this, find these cracks, and actually go down deep down into these cracks and do science for us, take pictures for us, and hopefully we can even find life on those places. So looking forward, finally, along with all the intelligent robots that we've been building for science and how AI is using that, one of the things that excite me the most is how the future of human exploration to Moon, Mars, and beyond could be enabled by AI. And this is something where this is a field that's just growing, and we need a lot of people, a lot of young people like you guys who can come and help us and support the mission of NASA and the world and help us do better science and build better and more intelligent robots that could help us for future exploration of our solar system. With that, I would like to conclude my talk. Thank you so much for listening in, and I'll be happy to take any questions. Thank you.
Thank you so much, Mr. Daftry, for that amazing presentation. In the interest of time, we will email the questions to you so that you can answer them. Students, please put your questions in the chat so that we can email as much as possible to Shreyansh so he can answer them for us. Thank you very much once again, Mr. Daftry, for that amazing presentation. Thank you so much, students, for joining these talks. And I really hope these presentations have triggered new ideas in your minds, generating new thoughts and aspirations for what you want to become when you grow up. Thank you again, Mr. Knowledge Shakundi, for organizing this wonderful festival and empowering students to make a positive change in the world through scientific discovery and innovation. Thank you, everyone. Bye.
Thank you, Anika. Thank you, Mr. Knowledge, for organizing this. Bye-bye.